Hi friends, good morning. In this video, we will learn about solvent effect on UV visible absorption spectra. Coming to the introduction, for a particular analyte, to select a suitable solvent, we need to know the solubility of that analyte. In turn, that solubility can be known from the chemical structure of that analyte. For example, analytes with polar functional groups are hydrophilic and they are soluble in polar solvents such as water or ethanol. Analytes which do not have polar functional groups and are hydrocarbon in nature are lipophilic and are soluble in nonpolar solvents like cyclohexane. Coming to our topic, solvent effects on UV visible absorption spectra. Our analyte may be polar or nonpolar. But solvent effect has very minimal effect for nonpolar analyte, whereas it has more effect in polar analyte. So now we will study about solvent polarity effect on polar analyte. In general, in UV visible region, there will be a pi to pi star and n to pi star transitions. First we will study pi to pi star transitions. Here we will take a sample with pi to pi star transition that is having a aldehyde group. See here, we have taken one sample with aldehyde group. When we supply energy, it undergoes pi to pi star transitions and goes to the excited state. Before undergoing pi to pi star transition, it is called HOMO, high energy occupied molecular orbital, which is less polar. And after pi to pi star transition, it is LUMO, low energy unoccupied molecular orbital, which is more polar. Due to pi to pi star transition, a partial positive charge is developed on carbon and partial negative charge is developed on oxygen. So because of these partial charges, there will be dipole-dipole interactions in LUMO state. So the polar solvent stabilizes the excited state. Polar solvent will stabilize this LUMO. In detailed way, if we have taken the same analyte in nonpolar solvent, this is what happens. This is the ground state. When we supply energy, it goes to the excited state, that is LUMO. This is the energy E1 we supplied here, and pi to pi star transition occurred. When the same analyte is taken in polar solvent, as polar solvent stabilizes LUMO due to dipole-dipole interactions, here only less energy is required when compared with this energy E1. E2 is less than E1 or E1 is greater than E2. That means lambda 2 is greater than lambda 1. Here the wavelength is more in the presence of polar solvent. That means polar solvent is causing the red or bathochromic shift. So polar solvent is promoting the pi to pi star transitions. Now we will see the samples with n to pi star transition in presence of a polar solvent. Here we have taken the sample with same aldehyde group. As we know, oxygen will be having two lone pair of electrons. When we supply energy, n to pi star transition occurs, and this is the case. What happens? Here in LUMO, there is only single pair of electrons as n to pi star transition has occurred. As HOMO is having two lone pair of electrons, there is a possibility of more hydrogen bonding with polar solvent. when compared with LUMO. LUMO is having only single pair of electrons, so it can form less hydrogen bonds when compared with HOMO, with the polar solvent. So here polar solvent is stabilizing the HOMO. In a detailed way, if we take that analyte in nonpolar solvent, this is the energy required for N2 pi star transition. When it is taken in polar solvent, this is the energy E2 for its transition, as it is stabilizing the HOMO. This is HOMO, this is LUMO, as it is stabilizing the HOMO due to more hydrogen bondings. The energy required is more in the polar solvent. That means E1 is less than E2, which is also equal to lambda 2 is less than lambda 1. That means polar solvent is causing blue or hypsochromic shift. So polar solvent can stabilize the HOMO and it is not promoting the N2 pi star transition. How to select a suitable solvent for an analyte? We have to go for a polar solvent in pi to pi star transitions and non-polar solvent in N2 pi star transitions. We should not select polar solvent in N2 pi star transitions because it will not promote the N2 pi star transitions. It is increasing the energy in case of N2 pi star transitions. Here let's answer few questions related to this topic. First one, solvent polarity has minor effect when sample is non-polar. You can pause the video and guess the correct answer. This is true. A solvent polarity will have minor effect when that sample is non-polar. Second question, in pi to pi star transitions, the polar solvent causes dash shift. A. Blue or hypsochromic shift. B. Red or bathochromic shift. C. Both A and B. D. None of the above. In pi to pi star transitions, the polar solvent causes red or bathochromic shift as the polar solvent stabilizes LUMO due to dipole-dipole interactions. Third one, the solvent to be selected for an analyte with N2 pi star transitions. A. Polar solvent, B. Non-polar solvent, C. Both. The solvent to be selected for analyte with N2 pi transitions is non-polar solvent because polar solvent will not promote the N2 pi star transitions. Thank you for watching. Please like, share and subscribe for more.